Good day and welcome once again to our class on the Fundamental Theorem of Calculus. Fundamental Theorem of Calculus. In today's class, we'll be evaluating the integral of x squared dx over the interval 1 to 3, the integral of 7 dx over the interval minus 3 to 4, the integral of 5x minus 2 dx over the interval 3 to 8. I am sure that at one point or the other, you have made use of the integral as a mathematics student, and you have solved questions involving integration. But in today's class, we'll be making use of the first fundamental theorem of calculus, the first version of the fundamental theorem of calculus in solving these questions that I have here. And what does the first fundamental theorem of calculus say? If you need to see the theorem on the first fundamental on the video for the first fundamental theorem of calculus, you can look back at the previous videos. You will find a video where I stated the theorem, the first version and the second version. You will find another video where I proved the first version, and another one where I proved the second version of the fundamental theorem of calculus. But today we want to apply the first fundamental theorem of calculus in solving these questions. So I begin by reminding ourselves what the first fundamental theorem of calculus says. It says if f of x is continuous, fundamental theorem of calculus, the first one, FTC1, says if f of x is continuous and differentiable on the interval AB with a differential of capital F of x to be equal to f of x, where f is Riemann integrable on the interval AB, then the integral of f of x over the interval AB is what? It is capital F of B minus capital F of A. But you will remember that we said that our capital F of x is what? Is the antiderivative of f of x. Now I begin with the first one. Integral x squared dx from 1 to 3. You will remember that by the time I integrate x squared dx, it's going to give us what? X cubed over 3 over the interval 1 to 3. And that gives us what? 3 raised to power 3 over 3 minus 1 raised to power 3 over 3. And that gives us 27 over 3 minus 1 over 3, and that is 26 over 3. 26 over 3. We take the second one, the integral of 7 dx from minus 3 to 4. By the time we integrate this, it gives us 7x over the interval what? Minus 3 to 4. And that gives us 7 into 4. This which we have gotten, or this which we got here, is our antiderivative of the f of x. X cubed over 3 is the antiderivative of x squared. The same thing as 7x is the antiderivative of that. And so by the time we input the limits of the interval, we have 7 into 4 minus 7 into minus 3. And that gives us 28 plus 21. And that is 49. Go ahead and do the third one. You can even pause the video and attempt it to see how much of it you can do yourself. The integral of 5x minus 2 dx over the interval 3 to 8. And that will give us what? Integrating 5x, I have 5x squared over 2 minus 2x over the interval 3 to 8. That gives us what? 5 into 8 raised power 2 over 2 minus 2 into 8 minus 5 into 3 raised power 2 over 2 minus 2 into 3. And so that gives us what? 5 into 64 divided by 2. Minus 2 into 8. That gives me 160 minus 16 minus 22.5 minus 6. So I have 144 minus 16.5, and that gives us 127.5. As I said before, you can pause the video and see if you can attempt the integral. All these are still algebraic expression, and the integral, for those who may not remember, the integral of x raised power n dx is what? X raised power n plus 1 divided by n plus 1. And that is what we have done here. The same thing we have done there. And then here also, we move on to the next one. The integral of x raised power 3 over 5 dx over the interval 1 to 32. By the time I integrate x raised power 3 over 5, that gives me what? 5 over 8 x raised power 8 over 5. You can try your hands on it using the integral formula. And this is across the bound 1 to 32. And so that gives us what? Gives us 5 over 8 into 32 raised power 8 over 5 minus 5 over 8 into 1 to power 8 over 5. And this gives me what? 5 over 8. The fifth root of 32 is 2, and that is 2 raised power 8 minus 5 over 8. And that gives us what? That gives us 160 By the time we solve this, we have 160 minus 5 over 8, and we have our answer to be 1,275 divided by 8. For the next one, the fifth question there, you can pause the video and try your hands on it. You are taking the integral of 5 over t raised to power 4 dt over 1 to 2. And this is the same thing as saying the integral from 1 to 2 of 5t raised to power minus 4 dt. And by the time we integrate that, we have 5 over minus 3 t raised to power minus 3. T raised to power minus 3. And that is over the interval 1 to 2. That gives us 5 over minus 3 minus into 2 raised to power minus 3 minus 5 over minus 3 into 1 raised to power minus 3. And so again, that gives us what? 5 over minus 3 into 1 over 8 plus 5 over 3. 1 raised to power anything still remains 1. And so we have this to be what? 5 over 3 minus 5 over 24. And that gives us what? Minus 35 over 24. That gives us minus 35 over 24. Moving on to the next one. Again, as I said before, you can pause the video and try your hands on it. Question number 6. It says we should integrate the square root of x dx over the interval 1 to 4. This is the same thing as integrating x raised to power 1 over 2 over the interval 1 to 4 dx. And by the time we integrate that, 2 over 3 x raised to power 3 over 2 over the interval 1 to 4. And that gives us 2 over 3 into 4 raised to power 3 over 2 minus 2 over 3 into 1 raised to power. This gives us 2 over 3. Square root of 4 is 2. 2 raised to power 3 minus 2 over 3. 2 times 8, that's 16 over 3 minus 2 over 3, and that is 14 over 3. We take the seventh one to pi over 3. The integral of cos theta d theta will give us what? Sin theta over the interval what? Pi over 3 to pi over 6. And so that gives us what? Sin pi over 3 minus sine pi over 6. And that's the same thing as saying sine 60 minus sine 30. Sine 60 is the same thing as 3 over 2, root 3 over 2 rather, minus 1 over 2. And that gives me root 3 minus 1 over 2. Moving to the 8th one. You can pause the video as I said before and try your hands on it. Integral sec squared theta d theta over the interval 0 to pi over 4. The integral of sec squared theta is tan theta. All this is just making use of is our prior knowledge on integration. Integral of algebraic fractions, integral of trigonometric fractions, and the like. Once we are able to recall that, it comes in handy. And that gives us tan pi over 4 minus tan 0. Tan pi over 4 is 1 minus 0. And so that is 1. We go to the 9th one. We are evaluating the integral of 5x into 2x minus x cubed dx over the interval 1 to 2. I can decide to expand that expression. The integral from 1 to 2 of 10x squared minus 5x raised to the power 4. And so by the time I integrate this, integral of 10x cubed over 3 minus minus x raised to the power 5. By the time we integrate this, 10x squared minus 5x raised to the power 4, it gives us what? 10 raised to the power 10x cubed over 3 minus x raised to the power 5. And we are integrating that over the interval 1 to 2. And so that gives us 10 into 2 raised to the power 3 over 3 minus 2 raised to the power 5 minus 10 into 1 raised to the power 3 over 3 minus 1 to the power 5. And so that gives us 80 over 3 minus 16, no 32. 2 raised to the power 5 is 32. Minus 10 over 3 minus 1. And so by the time we solve this, we have our answer to be minus 23 over 3. The 10th question there, it says we should find the area under the curve y equals to 2x squared from 0 to 1. I think I can just give us the hint on how to solve that, and you try your hands on it. Remember, we have said before that when they say area under the curve, they are referring to what? The integral. So we are told to find the area under the curve y equals to 2x squared. That's the integral dx from 0 to 1. And I'm sure we can attempt this and get the answer. You can drop the answer in the comment section. If you have benefited anything from this video, give it a thumbs up and share with your other colleagues so they too can benefit. Thank you. and God bless you. See you in the next video.